A newly discovered comet named C/2025 V1 Borisov has recently captured scientific attention and public curiosity due to its intriguing characteristics and the timing of its arrival. This comet, first observed on November 2nd by Crimean amateur astronomer Gennady Borisov, was detected only days before it began its rapid approach toward Earth. Its discovery caused excitement not only because new comets are always valuable to astronomers, but also because some of its features appeared faintly similar to those of the infamous interstellar object 3 I/Atlas. This similarity led to discussions, speculations, and even bizarre rumors suggesting that this new comet could be an offshoot, companion, or artificially deployed object connected to 3 I/Atlas. Yet despite these claims, researchers emphasize that C/2025 almost certainly originated from within our own solar system and bears no true relation to the interstellar visitor currently passing through. As scientists analyzed C/2025 more closely, they concluded that although it shares a few superficial traits with 3 I/Atlas, these are coincidental rather than evidence of a shared origin or extraterrestrial intent. On November 11th, the comet makes its closest approach to Earth, reaching a minimum distance of approximately 64 million miles, 103 million kilometers. This may sound close in astronomical terms, yet it is still roughly 270 times farther away than the Moon. Despite being relatively near, the comet remains far too dim for the naked eye, displaying an apparent magnitude of around 13.8. Stargazers equipped with moderate telescopes or high-quality binoculars may be able to spot it, especially during pre-dawn hours when it appears in the constellation Virgo. C/2025 V1 will continue its path through the inner solar system and reach perihelion, its closest point to the Sun, on November 16th. Observers tracking its brightness and structure note that the comet appears somewhat unusual. In early images, it seems to lack a visible tail, a feature commonly expected in active comets, as solar radiation vaporizes their icy surfaces. However, the absence of a tail does not necessarily suggest anything exotic. Some comets remain relatively inactive, and their dust or gas production may be too faint to create a dramatic tail. The comet's discoverer, Gennady Borisov, is already well known in the astronomical community for identifying the second confirmed interstellar object, the original comet Borisov, in 2019. That discovery made history because it was only the second time humans had observed an object that definitively originated from another star system. When 3 I/Atlas emerged earlier in 2025, it joined a growing but still extremely rare class of interstellar visitors. Because Borisov has now discovered a completely different comet during the same period that 3 I/Atlas is being studied, some people quickly formed connections that did not exist. The timing seemed coincidental, and the resemblance in orbital eccentricity added fuel to speculation. Prominent astrophysicist Avi Loeb even described C/2025 V1 as a nearly interstellar object, a phrase that caught attention and was widely repeated, often without proper context. What Loeb meant, however, was simply that the comet's orbit is more elongated than average, giving it an unusually straight and sharp trajectory as it approaches the Sun-high eccentricity can give a comet an appearance similar to objects that arrive from beyond the solar system, but it is not in itself proof of interstellar origin. Many long-period comets native to our solar system display comparable orbital shapes. This did not stop rumors from spreading online, especially because 3 I/Atlas had been temporarily hidden from Earth due to its position behind the Sun. While astronomers were unable to observe 3 I/Atlas for several weeks, C/2025 V1 suddenly appeared in the sky under somewhat dramatic circumstances. This coincidence inspired unfounded theories, claiming that the new comet could be an alien probe deployed by 3 I/Atlas or part of some coordinated extraterrestrial mission. Such ideas gained attention in fringe circles, fueled by misunderstandings and misrepresentations of comments made by Loeb over the years regarding the possibility of unusual or artificial interstellar objects. Yet in reality, no evidence supports the notion that either 3 I/Atlas or C/2025V1, is anything other than a natural comet. Loeb himself clarified in his latest blog post that C/2025V1 is not related to 3I/Atlas unless it exhibited some form of non-gravitational propulsion, something it clearly does not. Furthermore, the distance between the two objects at their point of closest approach was roughly 140 million miles, 225 million kilometers, far too large to indicate any physical connection or shared origin. Meanwhile, 3I/Atlas has completed its own perihelion passage, reaching its closest point to the Sun on October 29th. Its behavior during this period has been unusual and scientifically captivating. The interstellar comet displayed a sudden brightening event, a temporary shift in coloration, and an odd feature known as an anti-tail, a dust structure that appears to extend forward rather than behind the comet due to viewing angles and particle dynamics. Additionally, its surface appears highly irradiated, suggesting that it has spent millions or even billions of years exposed to harsh cosmic rays as it traveled through interstellar space before entering our solar system. Now emerging once again from behind the Sun, 3I/Atlas will make its closest approach to Earth on December 19th before continuing outward and eventually exiting our planetary system forever. Even though the comet's unusual traits have sparked speculation about artificial origins among some observers, astronomers emphasize that all available evidence remains consistent with natural cometary processes shaped by extreme conditions. Compared to this truly alien visitor, C/2025V1 is far more ordinary, though still scientifically interesting. Its high eccentricity, faintness, and tail-less appearance might seem peculiar to casual observers, but each of these features can be explained by normal comet behavior. Some comets produce very little dust or gas, especially early in their approach toward the Sun. Others may have surfaces coated in non-volatile materials that suppress activity until much closer to perihelion. The elongated orbit does not necessarily mean the comet came from outside the solar system. Instead, it may have originated from the distant Oort cloud, a vast spherical shell of icy bodies surrounding the solar system. Objects from the Oort cloud often exhibit extreme eccentricities because they spend most of their orbits far from the Sun and experience gravitational nudges from passing stars or galactic tides. These nudges can dramatically reshape their trajectories, sending them inward on nearly straight paths. C/2025V1's sudden discovery also illustrates how many objects still remain undetected in the outer regions of the solar system. Despite advances in telescope technology, countless small bodies drift in regions where they are too faint to be noticed until they travel closer to the Sun. The fact that astronomers detected this comet only about a week before its nearest approach to Earth is a reminder of how dynamic and unpredictable our celestial environment can be. Fortunately, the comet poses no danger to Earth despite its relatively close pass. Its orbit has been calculated with precision, and it is not on a collision course. Instead, it offers researchers a valuable chance to study a fresh comet, potentially revealing clues about the formation and composition of icy bodies in the solar system. As interest in C/2025V1 grows, so does fascination with 3I/Atlas, whose interstellar origins make it one of the rarest objects ever observed. Although some people continue to speculate about alien technology or cosmic probes, scientists rely on evidence, and the evidence consistently supports natural explanations. Both comets, one interstellar and one solar system born, provide opportunities for learning, not sensationalism. As they journey along their respective paths, astronomers will continue monitoring their behavior, measuring brightness changes, analyzing dust production, and refining orbital predictions. Each new observation adds to our understanding of comets as ancient time capsules that preserve material from the early stages of planetary formation. Ultimately, the story of C/2025V1 is not one of alien connections, but of scientific discovery, curiosity, and coincidence. Its arrival during the same period that 3I/Atlas passes through the inner solar system makes for an exciting cosmic backdrop, but they remain separate and unrelated travelers. While rumors may flourish among those looking for extraordinary explanations, the true wonder lies in the natural universe itself, vast, dynamic, and full of surprises waiting to be uncovered.